Hi, I'm Galila Asris. Can I start again? Hi, I'm Galila Asris. Welcome to the supersonic world of
differential equation.
Differential equation.
The differential equation.
Differential equation.
Differential equations.
Once again, differential equation.
Differential equations.
Sandwich. Ah! I always feel like somebody's watching me. Let's hear it for the boy. Da, 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 da. That the in the character, your mama, alive and kicking,
Is up, out of the paper.
After all that, to find the direction.
That trumpet takes a lot out of me.
What a big, lovely trumpet.
Look at me! I'm an apple chocolate. I like it I'm an apple juggler! Look at me! I'm an apple juggler! I'm an apple juggler! Look at me! Off with his head!
Give me one good reason why I should save your head.
I can tie a cherry stem into a knot with my tongue! No! I can explain vectors and kinematics, Newton's laws, circular motions, and I can tell you why my apples kept falling.
Yes?
It's because of the acceleration due to gravity, which is 9.8 meters per second squared at the Earth's surface, which, by the way, is round. Did you know that? Heretic!
Hi, I'm Tessa Monroe. Welcome to the gravity-packed world of physics, Part 1. Over the next 2 hours, we'll pick up where the apple chucker left off and tell you everything you need to know about physics, including scalars and vectors, one-dimensional kinematics, two-dimensional kinematics, linear momentum, Newton's law of motion, and friction. We'll even do some skiing, so let's get started.
Now we know that physics can be a really rough ride at times. The standard deviants have scoured the nation for all the introductory physics material that you need to know, and then hired some fantastic physics professors to help us. Now you can count on us to simplify this sciencey stuff and make it easy to learn, easy to remember, and just a little bit enjoyable. Believe it, it's our job.
But please remember, to truly understand physics, you have to go to class, read your books, and listen to your professors. The video works much better that way, okay?
Remember that this is a videotape. You can fast forward the tape through sections you already know. You can rewind the tape if you need to see something again. And you can pause the tape if you need to stop and take notes.
Now let me tell you a little something special about the video that you're watching. Because there are so many important formulas in physics, we have included an insert card with this video. These contain the equations you'll need while you study with this video. So stay tuned, my strong people.
Part 1. Introduction to Physics.
Section A. What is physics?
Physics is the study of how things work. Everything we do and use is governed by the laws of physics. We're submerged in it.
So why even study physics? Why do we have to know why things happen? They'll just happen anyway.
Well, so we can predict what's going to happen next. Like we can predict how long it will take to drive cross-country in the family bus, going at a certain speed.
Okay, here's an important thing to know. We're going to talk about physics as if we were living in an ideal world, just because in the real world there are so many things that must be factored in.
For example, in the real world, someone's speed would be affected by wind or rain.
The basic principles you learn for the ideal world are the same as those you use in the real world. It's just easier to learn the building blocks of physics through idealized models first, and then we can just adjust those models to the real world later on.
Section B. Using scientific notation.
In physics, we talk about huge things, like the universe, and tiny things, like molecules and atoms. So, in order to study physics in any kind of world, we've got to know how to write really big numbers and really small numbers. That's where scientific notation comes in.
What exactly is scientific notation?
Good question. Let's see.
Is it a language used only in science?
Kind of.
Is it poisonous to mere mortals?
No. Actually, scientific notation is a way of writing really big or really small numbers so they're easier to work with.
With scientific notation, we use exponents to express a number. So if I had $2 billion, that would be written as 2 times 10 to the 9th dollars. The 10 to the 9th part indicates how many zeros are after the 2.
Okay, here's a quick review for those